You know, what if the story we've all been told about the beginning of the universe is missing a really key detail? We tend to think of space-time and matter like a stage and its actors. One shows up and then the other. But what if that's wrong? A new idea suggests they might have burst onto the scene at the exact same moment. So let's just start with this mind-bending question. What came first? The universe itself, all the stars, the galaxies, the stuff, or the space for it all to exist in? It's the ultimate cosmic chicken and egg problem, and it's going to guide us through this whole explainer. To really get why that question is so important, we first need to get on the same page about the story that most of us have in our heads about how the universe began. The common story. This analogy, it just feels so intuitive, right? We imagine space-time as this giant arena, a pre-existing stage, a container. And then the actors, that's matter, energy, you, me, everything we see, they come onto the stage and the show begins. The container exists before its contents. It just makes sense. And this way of thinking leads to the timeline we're all pretty much familiar with. First, the Big Bang happens, and this space-time arena just expands like crazy. As it expands, it cools down. And only then, inside this stretching, cooling container, do particles finally start to form atoms, then stars, then galaxies. It's a really neat sequential story, one thing after another. But here's the twist. What if that really neat step-by-step story is actually built on a hidden assumption? One that we've all been making without even realizing it. And that's really the core question we're asking today. Is this arena first, actors second idea a hard scientific fact, something proven by all the data we have? Or is it maybe just a convenient assumption, an intuitive mental model that we've layered on top of the actual evidence? This idea is captured perfectly by this quote from our source material. Now, ontologically underdetermined is a bit of a mouthful, I know, but it's just a fancy way of saying that while we have tons of amazing data, we are empirically rich. That data doesn't actually force us to accept only one single story about the fundamental nature or the ontology of reality. This table here really breaks down how it all works. Look, we start at the top with empirical evidence. These are things we can actually go out and measure, like the afterglow of the Big Bang. From that evidence, we can deduce things, like the fact that the early universe was incredibly hot and dense. But that bottom row, the idea that space-time is a primitive arena that was there beforehand, well, that's an assumption. It's our interpretation, not a direct observation. Okay, so if the old story is just an assumption, how can we even think about this differently? We're going to need a new tool, a new kind of engine, to explain how reality could literally build itself. And this gets us to the really fundamental problem, right? How do you get stable, organized structures, things like an atom or a star, or even the very fabric of space-time itself, out of some chaotic, fluctuating, primordial nothingness? Where does all that stability come from? Well, the proposed engine for this is a process called constraint resonance emergence theory, or CRET. It happens in 3 steps. First, you just start with raw, random fluctuations. Think of it as just cosmic noise. Then, second, through something called resonant feedback, a few of these random fluctuations just happen to sync up and reinforce each other, and they amplify a specific pattern. And finally, this is the magic part, this stable resonant pattern becomes so dominant that it locks in and actually begins to constrain the behavior of its own components. It literally starts making its own rules. This locking in process is what we call strong emergence. It's the moment a system pulls itself up by its own bootstraps, so to speak. A brand new, stable level of reality just appears, one that's totally self-supporting and begins to dictate what's going to happen next. It's not magic, it's just organization becoming self-sustaining. Okay, so armed with this idea of strong emergence, we can now tell a completely different story about the dawn of time, a story of a joint debut. So here's the side-by-side comparison. The old idea was a hierarchy, space-time first, then matter second. The new idea, though, suggests a complementary partnership. Space-time and matter emerged together at the exact same time as 2 inseparable sides of the same cosmic coin. So the big question is, when could this joint debut have actually happened? Well, the source material suggests we can pinpoint a very specific, real moment in the universe's history for this to occur.
And that moment is called the QCD transition. This is when a chaotic plasma of quarks and gluons first got confined into stable particles like protons and neutrons. These are the very first strongly emergent material structures in the universe. Now here's the so-called coincidence. This is also the earliest point in time where our models of a smooth, continuous spacetime actually start to make any sense. The new interpretation says, hey, that's not a coincidence. That's one single event. The joint stabilization, the joint debut of both stable matter and stable spacetime.
And this whole idea is actually supported by some really deep physics, like the Wheeler-DeWitt equation. Now, you absolutely do not need to know the math here, just what it means. It basically says the universe is a closed system. There's no external clock ticking away somewhere, and there's no energy being pumped in from the outside. So all cosmic evolution, everything that has ever happened and will ever happen, has to be a process of internal reorganization. The universe builds itself from its own resources.
Okay, so this is a really fascinating alternative. But why does it actually matter? What really changes if we decide to adopt this new story of co-emergence?
Well, for starters, it completely reframes how we think about cosmic expansion. In the old view, expansion is this bizarre idea of a container literally stretching and somehow creating more space out of nothing. But in the new view, you don't have to create anything. Expansion is just the large-scale, dynamic reconfiguration of the rules, those geometric constraints that emerged along with matter. The universe is simply reorganizing itself internally, changing its own shape and scale as it goes. So let's wrap up with the key takeaways here. First, there's no primitive arena. Spacetime isn't a container, it's an emergent property. Second, the relationship isn't a hierarchy, it's complementarity. Spacetime and matter are inseparable partners. And third, the story of our universe isn't about actors on a stage. It's the history of new rules and new constraints emerging and then shaping whatever comes next. This whole new perspective really leaves us with a final and pretty profound question. If the universe isn't some finished performance playing out on a static stage, but instead it's a continuous process of co-creation, then what is it becoming? What new structures, what new rules are maybe emerging right now?